step down chopper with RL load. A step down chopper with RL load connected with a freewheeling diode. The circuit is as shown. During the turn on period, that is when time is between 0 and T on, when this chopper is closed, the average load voltage will be equal to the source voltage Vs, having a path that is Vs plus to the load RL back to Vs minus. During this stage, the inductor L charged from its initial position to the peak value or the maximum value, which means the load current gradually increases from minimum to its peak. During turn off period, that is the time t is greater than t on and less than capital T, the chopper is opened and the average voltage will be equal to 0. And the current path is from freewheeling diode to RL load back to freewheeling diode. Let this be I1 and this be I2. During this stage, the inductor discharges where its load current decay from maximum value to initial value. Now, the average current I average is given by I average when the chopper is closed plus I average when the chopper is open. Now, this is during chopper is closed. Vs equals to R I1 plus L divided by dt. Now, for average value, 1 by T integral 0 to T on Vs dt equals to R 1 by T integral 0 to T on I1 dt plus L 1 by T 0 to T on I1 by dt into dt. 1 by T Vs T on is equals to R. This is nothing but the average value. So I average plus L by T integral d I1. The I1 value is from minimum to maximum or initial value to maximum value. So I minimum to I maximum. This is nothing but the dt ratio K. So K Vs equals to R I average plus L by T of I max minus I minimum. Now let us solve this for I average. I average is equals to K Vs by R minus L by RT of I max minus I minimum. This is the average value when the chopper is closed. Let this be question number 2 and this be question number 1. Now, when the chopper is opened, this is the current path on the circuit. 0 equals to R, let this be I2 plus L divided by dt. For average value, 0 equals to R 1 by T I2 0 to T on dt plus L by T integral 0 to T on di2 by dt. R by I average when the switch is open equals to minus L by T integral di2. I2 coming from the peak to initial position, then I max to I minimum. Then you'll be getting L by T I max minus I minimum. I average when the switch is open is given by L by RT of I max minus I minimum. This is the equation number 3. Then from equation number 1, I average is given by adding these two, then we'll be getting K Vs by R. This is nothing but duty cycle multiplied by the source voltage divided by the resistance. This is the average current. Now, average load voltage. V average equals to 1 by T of integral 0 to T on Vs dt plus T on to T Vs dt. We know that during this period the voltage is 0 and this is only remaining voltage, then 1 by T Vs of T on. It is nothing but T on by T of Vs. So V average is equals to K of Vs, where K is the duty cycle, that is T on by T. Now the instantaneous current. During turn off of the chopper, Vd is equals to 0, that equals to IR plus L divided by dt. This equals to. During the turn on, the chopper is on, Vs equals to IR plus L divided by dt. From which you take I common, then R plus L d by dt equals to Vs. Let d by dt equals to some constant A. Then I R plus LA equals to Vs. This is first order differential equation. Therefore, the solution can be calculated as two components, that is I equals to I complementary function plus I partial integration. Now the complementary function, that I CF equals to R plus LA when ICF equals to 0, R plus LA equals to 0, from which A equals to minus R by L. Now the standard solution for this is ICF equals to A e to the power of minus R by L of T. Substituting A equals to 0 in this equation, that A equals to 0 in, let this be equation number A, equation A. Then we'll be getting what I partial integral of R equals to Vs. Now from which I Pi equals to Vs by R. Let this be P and this be C. Instantaneous current I is given by two components we need to add up, then Vs by R plus A e to the power of minus R by L of T. Now substitute the value of A. A is nothing but minus R by L. Vs by R minus R by L e to the power of minus R by L of T. This is instantaneous current I of T.